Okay, in this video we're going to be comparing exponential and linear functions. And we're going to start out with this example of a table in which we have two different functions. We've got f of x and g of x for all these values of x here in the top. And for each of these, for all my x values, I'm going to be calculating my delta x values. And for each of my two functions here, I'm going to be calculating, I'm going to call these delta y values. So I'm going to be calculating the change in my x values and the change in the values of my dependent variables, the change in the values of my function. So notice that for these two functions here, for all of these x values I've got, notice that all of my delta x's are the same. They're all plus 5. So the x values change by equal steps. And this wasn't that critical when we were looking at linear functions because we were just going to take the delta y's and divide by the delta x's to see if they were constant. Well, in order to determine if I've got an exponential function, it's actually important that the x values change by equal steps because we're going to be looking not just at the differences between consecutive y values, we're going to be looking at ratios. So I need these equal steps to be the same. I need the values between the different x values to all be the same. So the difference between consecutive values of f of x, notice if I calculate these differences here, my delta y values, the difference between these two is plus 15, plus 15, the difference between 1675 plus 15. The difference between each one of these consecutive y values is constant. Therefore, I know f of x is a linear function because delta y over delta x, in this case, all my delta y's, they're all 15. My delta x's are all 5. So delta y over delta x is always going to be 3 for any pair of points that I choose. All right, so I've got a constant value of delta y over delta x. That's the definition of a linear function. Well, the difference between consecutive values of g of x, if we take a look at our delta y's here, notice this delta y is 200, this delta y is 240, and this delta y, if I keep going, I can see they're all going to be different. All right, so I know right away that since the difference between consecutive values of g of x, these delta y values, is not constant, then I know right away that g of x is not a linear function. But let's take a look at not the differences between these consecutive y values, but let's take a look at the ratio. Notice that if I say 1200 divided by 1000, the ratio between these two consecutive y values, I get 1.2. If I take the ratio between the next two consecutive y values, 1440 over 1200, well, that is also 1.2. If I take the ratio between 1728 and 1440, that ratio is also 1.2. And if I keep going, if I check the ratio of every pair of consecutive y values, I'm going to keep getting this same value. And since this ratio of consecutive y values, since this ratio of consecutive y values is constant, these constant ratios indicates that g of x is an exponential function. Exponential function. So, for a table of data in which we have y equals f of x and the delta x is constant, those change in x values are constant, if the difference of consecutive y values is constant, then the data represent a linear function. If the ratio of consecutive y values is constant, then the data represent an exponential function. Okay, so for these two functions here in example 2, it says find a formula for each function in example 1. So for part A here, I know f of x is a linear function. And since I'm not given a value of f of x when x equals 0, that is, I don't know what the vertical intercept is, I'm going to use the, not the point slope, I'm going to use the slope intercept form of the equation of a line. And the slope intercept form, remember, is y minus y1 equals m times x minus x1. So I already know what my slope is. I calculated that before. My slope, delta y over delta x, that's 15 over 5, which is 3. So I know what my slope is. Slope is 3. So now all I need is a point. Well, I've got a whole set of points here. Let me just take this first set of points. X equals 20 and y equals 30. So x equals 20. Y equals 30. And let's see, I do a little bit of algebra here, and that gives me y minus 30 equals 3x minus 60. I add 30 to both sides, and I get y equals 3x minus 30. Now for part B, let me move part B over here. Part B, I want to find the formula for my exponential function. Well, for now, to find a formula for an exponential function, I'm just going to use my calculator. And if I put all of my x values into list 1 and all my y values into list 2, I can use my exponential regression function on my calculator. And that will tell me that my exponential function for g of x, let's go ahead and call it g of x, equals 482.25 times, I'm out of room here, times 1.037 to the power of x. So there's the formula for my exponential function. All right, let's take a look at a couple more examples. It says the following tables contain values from an exponential or a linear function. For each table, decide if the function is linear or exponential and find a formula for the function. Okay, so let's see. The first thing I notice is that all of my delta x values here are the same. So that's 1, 1, 1, 1. And I notice that all of my delta y values, let's see, 75 minus 65, that's 10. 85 minus 75, that's 10. That's 10. And that's 10. So right away I can see that delta y over delta x is going to be constant for any pair of points. It's always going to be 10 over 1. So delta y over delta x equals 10. So in other words, I know what my slope is. Turns out for this function, and I also know that makes this a linear function. So I know it's a linear function. I know the slope is 10. It turns out that for this data set, I'm also given this pair of points here, 0, 65, or the coordinates for that point. That tells me that my vertical intercept is 65. The value of my function when x equals 0 is 65. So I can use my slope-intercept form, and I can just plug into this form. Y equals, my slope is 10, my y-intercept is 65, and there is the formula for my linear function. Now this function here in part B, once again I can see that my delta x values, they go in equal steps of 1. And I notice pretty quickly that my delta y values, 600 minus 400 is 200, 900 minus 600 is 300. So right away I can see I do not have a linear function, because delta y over delta x is going to be different for at least for those 2 points. So I know I don't have a linear function. Well, let's see if I've got a exponential function. So let's see, I need to check all of my ratios here. 600 over 400 gives me 1.5. 900 over 600, if I punch that in, that gives me 1.5. 1350 over 900, I punch that in, and I again get 1.5. And 2025 over 1350 also gives me 1.5. Therefore, I know I've got an exponential function. So now I can just take my data points here. I'll put my x values into list 1 in my calculator. I'll put my y values into list 2, and I get a formula. Y equals 400 times 1.5 to the power of x. Now, my next example says find a formula for this exponential function. Well, it looks like that this would be pretty simple. All we need to do is put our x values into list 1, put our y values into list 2, and use the exponential regression function on our calculator. Unfortunately, if you do that for this particular set of data, you get an error. And so in order to find the formula for this exponential function, our calculator is not going to be able to help us, so we're going to have to find a different method. And we're going to take a look at that in the next video.